Hello my dear friends, welcome to our channel. So in the previous lecture we started the properties of charges and we discussed two properties, that is first one is charge is transferable and the second property we studied is charge always exists with mass. Right, so here is a third property, that is invariance of charge. What is invariance of charge? Charge does not changes with the speed of a body. With the speed of a body, right? Charge does not changes with the speed of a body. Let us understand this. For example, I'm having a pen here, right? For example, it is having a charge of 5 coulomb, right? I think I forgotten to give you the SI unit of the charge. SI unit of the charge is coulomb. This COULOMB, coulomb, and its representation is capital C, right? So it is a SI unit of charge, that is coulomb, and the representation is capital C. You just remember this one. Yeah, so I'm here. Charge does not changes with the speed of a body. For example, let us consider this is a body. This body having a charge of 5 coulomb, and if I'm just going to throw this body with a velocity of 10 meter per second, right? It is a pen here and I'm just throwing this pen with this velocity of 10 meter per second. So once if I throw this pen with a velocity of 10 meter per second, the position of this pen is going to be get changed. That means it is moving with some velocity. That means this body is going to be in the motion. So while the body is in the motion, do the charge magnitude is going to change or not? Do the charge value is going to change or not? Because it is just having 5 coulomb. So once this body is going to get into the motion, whether this body charge is going to get increase or decrease, or it is going to be the same. So here the answer is it remains same. Charge value remains same even when the speed increases or decreases, or it is at the rest state. The body always have the same magnitude of charge present as before it has while it is in the rest state or while it is in the motion. So already I said, while studying the intrinsic property of matter, mass is also an intrinsic property of matter. I spoken about here about the charge. The charge does not changes. The magnitude of the charge does not changes with the speed of a body. Even the body moves with 3 into 10 to the power 8 meter per second with the speed of light. The value of the charge, the magnitude of the charge is not going to get vary. The value of the charge is always remains same. That is what known as invariance of the charge, right? So I was speaking about the mass is also an intrinsic property. Everybody knows one. Does mass changes with the speed of a body? Yeah, mass changes with the speed of a body. How we are saying this one? So here Albert Einstein given us the relation one here, that is m is equal to m naught upon under root over 1 minus v square upon c square. It is the equation given by Albert Einstein. M stands for moving body. M stands for mass of a moving body. Mass of a moving body. M naught stands for mass of the same body at rest state. Mass of the same body. The body should not vary. The body should be the same. Mass of the same body at a rest state. At rest. Right? And here V is the speed of a body with what velocity it is moving, with what speed it is moving, the object, right? It is V upon C. C stands for speed of light. C stands for speed of light. So let us understand this one. It is the mass of the moving body. Now I am going to assume that a body A is moving with 100 meter per second. Yeah, I'm just assuming that I'm having an object which is moving with a velocity of 100 meter per second. As this pin is going to move with 100 meter per second as I'm throwing, right? So as this pin is going to move with a velocity of 100 meter per second, whether the mass of this pin going to vary or not. Okay, right. Here it is moving with 100 meter per second, so I am just going to substitute the value here, just v square upon c square. Wait, yeah, v square upon c square. So as it is going to be 100, as it is going to be 100 meter per second, and it is 3 into 10 to the power 8 meter per second. So here the denominator is very big. Here the denominator is very big. If the denominator is larger than the numerator, then the value going to be less than 1. How I am saying it is going to be less than 1? Let us understand here. 1 by 5. Here the denominator is larger than the numerator. Let us cancel out this one. What I am getting? 0.2, which is lesser than 1. It always happens. If the denominator is larger than the numerator, then we get the value as less than 1. So here the value is going to be less than 1. So here v square upon c square is solved. Now 1 minus v square upon c square, that is 1 minus lesser than 1. 1 minus lesser than 1, what we will get? We will get lesser than 1. How I am saying 1 minus lesser than 1 is lesser than 1? Because 1 minus, just assume it is 0.2 is nothing but a 0.8, which is less than 1. So 1 minus a lesser than 1 value is always going to be less than 1. It's a mathematics, right? So I just got it. I just got a 1 minus v square upon c square as lesser than 1. This value is lesser than 1. Now I'm going to this part. I'm going to write it out here. 1 minus v square upon c square is lesser than 1. I'm going to write out this part, that is m is equal to 1 into m naught. I can write it as 1 into m naught upon under root over 1 minus v square upon c square, right? It is the equation which is given by Albert Einstein. So here, as you can see here, it is 1 upon less than 1. 1 upon less than 1 is always going to be greater than 1. How I am saying 1 upon less than 1 is always greater than 1? See here, 1 upon 0.2, 1 upon 0.5. So here it is 2 times, right? 0.5 2 once, it is 5 times. So here, as you can see, the denominator is lesser than 1. If the denominator is lesser than 1, then we get the whole value is greater than 1. Here, as you can see, 1 upon lesser than 1, that's why I wrote it is greater than 1. Therefore, instead of writing 1 upon lesser than 1, 1 minus v square upon c square is lesser than 1. So 1 upon lesser than 1, I can write it as m is greater than 1 into m naught, that is m naught. So m is greater than or equal to, you can say, when the mass of a moving body is going to be equal to the mass of the object at the rest state. When it happens at the macromolecules, at our level, it is going to be approximately equal. Not it is exactly equal, it is going to be approximately equal, because we are very massive. We are a macro, that means macro bodies. So that's why I'm saying for electron and all, we can compare the masses. The masses changes with the velocity. The electron mass changes with the velocity of the particle electron. All right, so here we can prove that the mass of a moving body, is always greater than m naught. M is greater than m naught, mass of the object at the rest state. The object should be the same. So with the help of Albert Einstein equation, we can prove that the mass of a moving body changes with the speed of the object. See, I'm just giving you the conclusion. We came to know about two matters, that is mass and the charge. These are the two matter which comes under intrinsic property, as it is present naturally in the nature. That is why we are saying that it is an intrinsic property of a matter. So as we are studying about the charge, that's why I just given you told the information about the mass, that a mass changes with the speed of body, but the charge with whatever velocity may you have thrown the object, there is no effect. it is not going to change the value of the charge, whatever may be the velocity you may put up. Right, but in case of mass, the mass changes with the velocity of the object. Right, if the velocity of the object is comparable with the speed of light, you will study in quantum mechanics, then you will come to know about that mass really changes with the speed of a body, but the charge is not going to change with the speed of a body. That is what the third property of the charge, that is invariance of charge. So in the next lecture, we will study the most important property, that is conservation of charge, and we will discuss the conservation of charge with some problems too, and we will do some problems based on the conservation of charge. If you do like this video, then share with your friends, subscribe it, comment. If you have any doubt, you can ask me in the comment section for sure. Your doubt will be clarified soon.